Identify the physical processes from the heating curve. By examining the heating curve for methane, the process occurring at the horizontal plateau at 90 Kelvin, plateau Q, is melting, fusion, and the process occurring at the horizontal plateau at 110 Kelvin, plateau S, is vaporization, boiling. Understand the molecular behavior during melting. At 90 Kelvin during melting, solid methane transitions to liquid methane. In this transition, the rigid crystal lattice is disrupted, allowing the molecules to flow past one another. However, because the molecules in a liquid remain in close contact, their intermolecular attractions are only partially disrupted or weakened, not completely broken. Understand the molecular behavior during vaporization. At 110 Kelvin during vaporization, liquid methane transitions to gaseous methane. In the gas phase, molecules are extremely far apart and move independently of one another. To achieve this state of complete separation, intermolecular attractions must be completely overcome. Relate the extent of IMF disruption to energy requirements. Because completely overcoming intermolecular attractions requires a massive input of energy compared to simply weakening them, vaporization requires significantly more energy than melting. This is reflected in the fact that the enthalpy of vaporization, delta HVAP, equals 8.2 kilojoules per mole, is nearly 9 times larger than the enthalpy of fusion, delta HFUS, equals 0.94 kilojoules per mole. This confirms option A is the correct statement. The correct answer is option A. Intermolecular attractions are completely overcome during vaporization.